So in our talk, we would like to introduce Knora, a system for the storage of primary source materials and research data in the humanities. Knora stands for Knowledge, Organization, Representation, and Annotation. This is why it's pronounced Knora and not Knora. And the main goal is to make data available and reusable on the long term. So that could mean things like you would like to do research across repositories, looking for documents that mention a particular person, like a historical person that is identified, or you would like to interlink two resources held in different repositories, or you would like to do natural language processing about documents held at different places, or you would just like to reuse existing research data, but in a way that later researchers would see what you have added to it and what was already there before. So, to illustrate this, we took the example of an edition. So, the examples are taken from a printed edition, but the model is quite flexible. It's the critical edition made by Sattler about the works of Hölderlin. So you could think of it as an accumulation of layers of interpretation. So on the upper left, you see a facsimile or a scan of the original manuscript, and on the right, you see the diplomatic transcription. So it's a more or less accurate transcription of what stands where on the page. And in a second layer, you could add to it an analysis of the writing process. So it's a genetic analysis. And in the end, you can see it below, you could put your constituted text. And even though it's a printed edition, the user could really see the different layers of interpretation that were added. And this could be some kind of metaphor what we would like to do in our project, so that you could add layers of interpretation and that everyone else after you could see what you have done. So the problem we face in our days is that we have a lot of repositories, but most of them are just made for the human end user that is looking at an HTML page. So mainly it's collection of web pages, of images, of PDF files to download. Some of them do offer APIs, interfaces that are machine readable, or even Spark and endpoints. But in general, every project has its own standard. So for every project, you would need to implement an own gateway or driver in order to make it work with the virtual research environment of your choice. So our approach is that we have a very flexible and generic technology for storage and representation of data, which is based on RDF. On the one hand side, it's generic and flexible, but on the other hand side, it also has to be able to represent specific semantics of single projects. And to make it available to the outside world, we implement an API so that it's easy and convenient to access the data, to make queries, or even to add to it of the application of your choice. So let's give you a short overview about related work. So I think the most of you know the TextGrid project, which has two main parts. One part is the laboratory, which is based on Eclipse. It's kind of a plugin for Eclipse. And there you can create digital editions of texts in TI XML. So there is an XML editor. You have dictionaries you can access. You can search through the repository, connecting over the internet. And there's also an editor to make links from parts of facsimiles to parts of the XML file. And on the other hand side, you have the repository, which allows for collaborations because you can store your files in a central position. And you also have access and permission control. And the repository's contents are also available on the website forming out the digital library. However, this approach seems, to us, it seems quite limited to the needs of this TI-XML community. So another project is Europeana. So it allows you to search around a lot of repositories just by using one interface. So there are a lot of repositories in there, archives, museums, libraries. But the problem is to access the full quality resources, you're redirected to the holding institutions. And this is because Europeana demands the repositories to send their metadata in the EDM format, and you just put a hyperlink to your full quality resource, so they really don't actually know what it is about, what its resolution or quality is. So you don't really have the means to work with the resources you have found using Europeana. Another project important to mention is DANS, which is part of the Dutch National Archive. One of its main parts is the easy archiving system, so it allows you to upload files to add metadata. So that will be stored on the long term, and you can do a search using this metadata, and when you found something, you can download the file. The problem here is, I tried it before I came here, and I found a Word version 9 file, which is not really an archiving format. However, it is connected to the NARGIS system, which is kind of a register for publications, researchers, and institutions. Isidore, this is a metadata project, so I actually collected a lot of metadata among repositories, and what they did is they represented all of it in RDF and made it available in 3 languages, in French, Spanish, and English. They also offer a Sparkle endpoint, but there the problem is the same like in Europeana. If you want to access the resources themselves, you have to go to the repositories that originally hold them.
So now I'll take over for a minute. Fedora Commons is a more general purpose project. It's a content repository platform that implements and extends the linked data platform, which is a W3C recommendation defining rules for accessing resources over HTTP. And these resources can be represented either as RDF or as binary data. So following the linked data platform spec, Fedora gives you returns RDF triples directly to the client. And we think this doesn't offer a lot of convenience over running Sparkle queries yourself. And we also think RDF is great as a data storage format, but cumbersome as an API format. And in any case, you couldn't actually run Sparkle queries in Fedora because its underlying storage system is not RDF. It's based on the Java Content Repository API, which assumes that repositories are inherently hierarchical. And in fact, Fedora requires a repository to have a tree structure to provide acceptable performance according to their own tests. So we think it's probably not well suited to data that's basically structured as a graph rather than as a tree. Fedora's API extends the LDP specification somewhat by offering its own ontology, which it uses for the RDF that it generates, but it doesn't seem to be designed to enable clients to work with heterogeneous data in a unified way. So now I'll give you a brief overview of the Knora project and how we aim to solve the problems we've described. Knora is being developed as a generic platform for storing and accessing digital humanities, digital sources and research data in the humanities. It offers a set of OWL ontologies that define basic abstract concepts that are common to different sorts of data in different disciplines. So each research project that uses Knora has its own ontology that describes the structure and semantics of its data and extends these abstract concepts that Knora provides. And this allows Knora to adapt to many different kinds of data while allowing all this data to be queried and manipulated and added to in a consistent way. At the same time, Knora offers an HTTP-based API that provides convenient access to data using these abstract concepts, so clients don't have to work directly with RDF triples. And as we'll see, this allows a virtual research environment to query data and to do a lot of useful things with it without knowing the details of its structure or semantics. The Knora project is a key element in the strategy of the Swiss Academy of Humanities and Social Sciences for the long-term availability and reusability of humanities data. And for the past 2 years, a pilot project establishing a data and service center for the humanities has been carried out at the universities of Basel, Lausanne, and Bern. And a variety of different repositories and different humanities disciplines have been imported into Knora. And all this data can now be annotated and reused in a unified way through the Knora API. This is a very confusing diagram, which you can't read, it's okay, of the Knora base ontology. So we won't have time to cover all the details, so I'm just going to introduce key concepts. The main abstractions used in Knora's ontologies are called resource, property, and value. And these are based on the core concepts of RDF. But Knora's ontologies give them more specific definitions to make them more useful for representing humanities data. So about resources. In Knora, a resource is defined as an OWL class, and it can represent absolutely anything, including physical things like people, a sculpture, a manuscript, or abstractions such as historical events, or digital content such as a photograph of the sculpture or a transcription of the manuscript. Each project that uses Knora defines its own subclasses of resource to represent the kinds of things it deals with. The Knora ontologies define certain common ways that resources can be related to other resources, and these include part-whole relations, like between a book and its pages. So you can query a book to get its pages, and you can query a page to find out what book it's in. You can represent arbitrary links between two or more resources. So a link itself can be a resource. And this means it can have its own metadata, such as information about who made the link, when it was made, and why, and so on. And Knora provides a way of representing annotations. So anything can be annotated, including links and other annotations. You can have annotations, of links, of annotations, and so on. About properties. A resource has properties with values that contain data about the resource. Each project defines its own properties that are relevant to its resource classes. And each resource class specifies the properties it can have using OWL cardinalities. So for example, letters can be defined as having senders and addressees. Photographs can be defined as having photographers, and so on. And this makes it possible for Knora to query the project's ontology to find out how to create a new resource, like a new letter, based on its resource class. Using OWL cardinalities makes it possible to enforce database integrity. For example, if a stained glass window is allowed to be in only one building, Knora can ensure that you don't put the same window in two buildings. And about values, RDF has standard data types such as strings and integers, which are borrowed from the XML schema standard, but typical humanities data needs more complex data types. For example, the standard string type provides no way to represent formatting or links. And the standard date type can't handle dates in different calendars or dates that are uncertain. So Knora defines all value types using OWL classes rather than simple literal types. For example, a Knora text value supports text containing standoff markup. And Knora stores markup as a graph of RDF resources, which are separate from the actual text. This allows you to create different markup layers referring to the same text. Knora can also support non-hierarchical markup, such as markup with overlapping tags. And if the markup text contains links to other resources, these links become RDF triples, so Knora can easily query them. So by using RDF as a storage medium, Knora allows you to do things with text that might otherwise require a specialized XML database, for example. And we plan to support other types of markup as well, and we're working on a way of automatically converting TEI XML documents to RDF and back. Similarly, A Knora date value is designed to support comparison of dates in different calendar systems, as well as dates having different degrees of precision. And we do this by representing each date as a range of calendar-independent Julian day numbers. So, for example, if you have just a year, but no month or day, Knora stores the date as a range, going from the beginning of the year to the end of the year. And this means you can search for dates, or for example, you can search for a book having a certain publication date without knowing what calendar systems the dates are actually in or how precise they are. And finally, Knora values are versioned. Normally, Knora doesn't delete or modify existing data. It just adds a new version of a value and keeps the old one. And this means you can always revert to an earlier version or get a snapshot of your data as it was at a given point in time. RDF repositories often provide query services using the standard SPARQL query language, but we think this wouldn't be the best approach for Knora for several reasons. First, SPARQL is hard. For example, the difference between efficient and inefficient SPARQL can be very subtle. Most clients are not expected to have the expertise or desire to master the fine art of SPARQL. And sometimes the most efficient SPARQL produces results that are inconvenient to work with. For example, if your data has a tree structure, as in this example, you don't want a flat list of triples in a table as a result representing the tree. And RDF and SPARQL don't have any standard concepts of versioning or access control. So to solve these problems, in response to a simple HTTP request, Knora's API generates and executes correct, efficient SPARQL queries, some of them quite complex. And it then transforms the query results into JSON data structures that are easy for clients to use. If you ask for a tree, Knora gives you an actual JSON tree, which is much more convenient to work with. And the Knora API provides versioning and access control in a way that works with all RDF triple stores, using concepts of users, groups, and permissions that are defined in the Knora ontologies. The current Knora API is based on use cases from our experience writing a web-based graphical user interface, a GUI, for a virtual research environment called SALSA, which stands for System for Annotation and Linkage of Sources in the Arts and Humanities. And this system is being used by a number of research projects in different disciplines. So the API offers operations that are typically needed by a GUI, such as retrieving a resource with all its properties and their values so they can be displayed together. I'm going to run out of time, so I'm going to speed up a bit. It's also possible to implement the Knora API as a gateway to other types of repositories, including non-RDF repositories. And we've already done such gateways for two repositories. ECODIS is a virtual library of modern manuscripts of Switzerland, and eLib, a repository of materials such as manuscripts and rare books in Swiss libraries. And both of these repositories consist of images with metadata. The idea is basically that we can access, Knora can access the data in the remote repository and present it through its API, for example, to somebody using a virtual research environment, as if it was local data stored by Knora. And then the user can annotate it, add to it, or work with it in all sorts of ways. And if they add something, what they add will probably be stored locally in their local Knora triple store. But they don't have to worry about where the original data is stored and where their additions are stored. It all appears to them together in their user interface. And now, back to Tobias.
So, let's present me a use case for this. So, one of the projects that is part of SALSA and Knora for a long time is the Anton Weber Gesamtausgabe, which is a project for musicology. And actually now they do all of their editorial work using Knora and SALSA. Recently they made an own website to present the project. And as far as now, they just put hyperlinks to certain resource types in SALSA. And of course then when you click on the link, a new window opens in your browser. And of course this is not the way we would like to embed SALSA in another website. So they should rather use the Knora API to do this. So the solution we're aiming at in the near future is that they could integrate their resources by querying the Knora API directly, and to embed the resources directly in their website using their CSS and their design. And actually every project could build its own interface using the Knora API. So they wouldn't have to use the Salsa GUI to present their resources to the public. Another example would be the Bernoulli-Euler online project, which aims at unifying two editions in one digital platform. One of those editions is already digital, the other one is printed, but the more recent volumes are available in LaTeX, so we could import it into the Knora environment. And the idea is, as Ben explained for two other projects, to create gateways to other edition projects that have thematically related material, such as the Newton project, which relies on XML, TI XML files, or the Leibniz archive, which has some of the printed volumes available as PDFs. And the idea is that we could make all of this available to the user to do the research. Back to Ben.
The initial prototype of the Knora API was developed in PHP using a relational database to store data in an RDF-like way. But we're now re-implementing it in the Scala programming language using true RDF triplestores. Scala is a strongly typed functional language targeting the Java virtual machine. By using a functional language, we've been able to pretty much eliminate shared mutable state from the API server, and this has made it much easier to prevent bugs. Scala also has a modern concurrency model known as the actor model, which is implemented by a library called akka. And this means that the application is broken up into services called actors, which talk to each other using messages. These actors can then be distributed over multiple servers, multiple machines, and this means that it will be easier for the API server to scale to support large numbers of concurrent users. Knora aims to be an extensible framework. Since Scala and Java are interoperable with each other, developers can extend Knora by taking advantage of the many Java libraries available for processing humanities data. For example, there are many good Java libraries for natural language processing that could be integrated into Knora. Another way to extend the Knora API would be for projects to add their own Sparkle queries and Scala actors to provide project-specific API operations. Or you could embed Knora in another application written in Scala or Java to use the Scala actors directly without having to talk to Knora over HTTP. Version 2 of the API, which we're working on now, will be designed to better support a wider variety of client applications, not just GUIs. So, for example, a non-interactive application written in any programming language could do batch processing using the Knora API. And we'd like to support in version 2 queries spanning multiple repositories, probably using Sparkle federated queries. So you'd be able to do a search, for example, and get a single set of results gathered from multiple repositories, then work with those results without worrying too much about where they're located physically. And probably we'll also support in version 2 the JSON LD standard for linked data. This would allow the Knora API to produce JSON that's human readable and easy for web developers to work with, but also has semantics defined in terms of RDF to facilitate automated processing. And finally, of course, for version 2, we have to redesign some parts of the API because it grew over time in an organic way and has some inconsistencies and redundancies that need to be cleaned up. So, in conclusion, what we're proposing is a distributed architecture in which a virtual research environment or some other client software can talk to a Knora API server, which in turn can talk to other Knora API servers or Knora gateways to non-Knora repositories. And this would enable a user working in a virtual research environment to work with materials from different repositories without having to worry about how or where they're stored. The Knora source code and ontologies will soon be freely available this year, I hope, so as open source. So anyone will be able to contribute to the project, and I hope that will that you will all comment and send us feedback and ideas. Thank you very much.
So, floor is open for questions and comments. German or English? Do you take questions in German?
Tobias will take the questions in German.
I'll translate them. I speak some German. I'm Swiss.
No.
He asked how many people.
You work with the project from a technical point of view?
We have, I think, 4 full-time employees.
Yes.
And a couple of PhD students. It's quite a small team because we also do other things. So at the moment, I'm the only one who's really working on it full-time. Everyone else is busy with other things, but we hope that that will change soon.
We do have a resource problem.
Yeah.
As soon as JSON LD becomes more standard, for example, implemented in triplestores like Virtuoso, how big is the advantage of Knora over Virtuoso then?
Well,
or what does it give you other than the ontology?
As far as I understand, the idea of JSON LD is that it's really quite generic. You can represent any RDF triples in JSON LD. So, what Virtuoso might just give you is basically a list of triples or represented in JSON LD, which is not necessarily a big advantage over just getting back a table. So what we're offering is more, for example, you would get in a standard API request to Knora, if you ask about a resource, you're going to also get as sub-objects in the JSON, for example, information about other resources that link to that resource, or child resources, or information about who owns the resource, and so you can. The idea is you can create. JSON. The advantage of using JSON is that you can make a real tree structure, with sub objects and it's. For example, one of the things that Knora supports is this idea of hierarchical lists, which is something that's quite often needed in the projects that we've worked with. So, for example, you want subcategories, categories and subcategories of things in your repository, like photographs of places, photographs of people, and so you have subcategories. And the idea is that you'd like to be able to, for example, get the whole list. If you do this just by doing a Sparkle query, well, first of all, it's a tree represented in RDF, so the way you're going to have to get it back is as a table. Sparkle always returns results as a table. So the naive way to give you this in JSON LD would just be to make a table in JSON LD, and that's not what you want. I don't know what Virtuoso is going to do, but what Knora would do is give you a tree, which is what it is, represented as JSON.
Whenever I see projects that seem to implement a middleware between the application and some service down below, and the development of the service down below may be faster than the development of the middleware, your project becomes less and less adding value over time.
Well, in this case, it would be great if some of the things that we're proposing became standardized.
Yeah.
I have in the back of my mind the idea that some of this could be eventually submitted as standards track proposals, for example, to be standardized by the W3C. I think there's a need for it. Maybe not exactly the way we're doing it, but for example, the idea of storing dates that are suitable for humanities data as Julian day numbers. As far as I know, no one else is doing this. And it would be great to see it standardized. We would be so happy, that would be less stuff for us to maintain. But I think the idea that there's some added value in an ontology that's specific to humanities data and an API server that gives you results in a structure that's more convenient than just SPARQL query results, probably there'll be some value in that for some time. I mean, maybe someday no, maybe someday all of that will be standardized and we can go away. I think that wouldn't be such a bad thing, personally. But for now, no, it's not there.
Okay, there's time for one more quick question.
You explained, and I fully agree that SPARQL is a hell to work with. What kind of query language do you implement instead?
Well, the idea is just that you make an HTTP request. So here, for example, I don't know if it's legible, but the idea is you make an HTTP GET request to our API server, and it says /resources/ the URL of the. So in RDF, everything has an IRI. It's like a URL that identifies it uniquely. So I want the resource that has this identifier, and I get back.
Who was born before 1900?
So this you would do is there's a search endpoint for the API. So you do, instead of /resources, you do /search, and then you'd say, I want a resource that's of this type, a person, that has this property, date of birth, which is less than this date, 1900. And you could put all of that as query variables in the query string.
And actually, if you use the Salsa front end, and if you have something like Firebug enabled, you can see what kind of request it sends to the API, because the GUI is fully integrated with the API endpoint.
The GUI is actually just a JavaScript application runs in a browser, and it sends requests to the API server. So when if you have a search form where you could do something like that, query, who was born before 1900, you would pull down, resource type to person, and property that you want to search about, birth to date of birth, and you would type in 1900 less than, and that would just generate this URL to make a GET request to the API server.
I think I cut it out here, but
Okay.
much more time. So let's thank the speakers again.